Mankind has always been driven to tinker and create. Since the discovery and taming of fire by our ancient ancestors nearly 500,000 years ago, the history of our species up to this present day has been awash with the development of countless inventions that have made our lives better and have helped us better understand and adapt to the world around us. But for all of humanity's scientific and technological developments throughout the millennia, no single invention has been as important to the history, present and future of our species as the James Webb Space Telescope. To understand why that is the case, we first need to observe and analyze the history of astronomy. You see, humans have been gazing at the heavens above for thousands of years, trying to understand the nature and importance of the shining tapestry of celestial bodies strewn across the night sky that can be seen with the naked eye. But for all our collective intellect, for thousands of years, our observation and understanding of the cosmos was limited to what we could see with the naked eye. There were no dedicated tools or instruments to aid us in mapping the heavens, which is perhaps why early astronomers believed that the cosmos was uniform or unchanging, with the Earth at its center. That all changed in 1609 with Galileo's invention of the telescope, which for the first time ever allowed us to see the stars and other planets up close, with a 15 to 20 times magnification. This revolutionized the world of cosmic science, directly leading to Galileo discovering sunspots, seeing craters on Earth's moon, observing the moons of Jupiter and the phases of Venus, and realizing the Milky Way is made of billions of individual stars. Henceforth emerged the scientifically correct understanding that Earth is not the center of the universe, and all the planets in our solar system actually revolve around the Sun. The next major breakthrough in astronomy of this magnitude didn't occur until over 300 years later, on the 30th of December 1924, when astronomer Edwin Hubble discovered the nebulous Andromeda galaxy and proved that our own Milky Way was but one of the countless galaxies in the vast expanse of the universe. Then came the creation and launch of the iconic Hubble Space Telescope, an idea that had been conceived since the 1940s but wasn't launched until April 1990. Named after the renowned American astronomer, the solar-powered Giant Space Telescope has helped astronomers better understand the formation and evolution of galaxies, discovered that most galaxies have a supermassive black hole at their center, imaged some of the farthest galaxies ever seen, and mapped the presence of the mysterious entity called dark matter, which makes up most of the mass and structure of the universe. And while the Hubble continues to make new discoveries, taking stunning high-resolution images of stars, planets, galaxies, and nebulae to this day, we finally come to the story of its successor, the James Webb. Built over a period of 30 years, and with the cost of development reaching a whopping $10 billion, the James Webb Space Telescope is a monumental scientific and technological achievement that will shape the world of astronomy for decades to come. Christened after NASA's Kennedy and Johnson era's administrator James Edwin Webb, it is the most powerful space telescope mankind has ever constructed, primarily designed to conduct infrared astronomy. Its high-resolution and high-sensitivity instruments allow it to view objects that are too old, distant, or faint for the Hubble Space Telescope to detect. It was officially launched on the 25th of December 2021, and unlike the Hubble, the James Webb orbits the Sun rather than Earth, at a distance of 1.5 million kilometers from our planet on Lagrange point L2. And even though it's just celebrating its second birthday in space next month, in that brief period of its planned 20-year cosmic journey, it has already made breakthrough discoveries that are reshaping our understanding of the universe. One of the most important of these is the observance of some of the most distant galaxies in the observable universe, which are believed to be nearly 13.4 billion years old, forcing astronomers to rethink conventional ideas about how galaxies formed in the early universe following the Big Bang. Other important James Webb accomplishments include detailed images of the atmospheres of various exoplanets, the discovery of hidden star formations due to the collision of galaxies, the birth of stars in the Eagle Nebula's Pillars of Creation, the uncovering of countless new galaxies in the Hubble ultra-deep field, the detection of the largest and most distant supermassive black hole in the universe, the finding of never-before-seen stars in the Tarantula Nebula, and the clearest view of Neptune, as well as Jupiter's giant red spot. What makes all of this possible is the ability of the near and mid-infrared based space telescope to peer through dust and gas in the cosmos, revealing new details of galaxies, nebulae, stars, planets, and black holes that would simply not be possible for the Hubble telescope, which is primarily based on observing visible and ultraviolet light. And all of this is helping astronomers peer farther back in time to the early history of the universe like never before. For all of its remarkable achievements in the 2 years since it was launched, the James Webb Space Telescope is not just changing our understanding of the cosmos, it is also helping us improve our lives here on Earth through new innovations in technology that have applications beyond the telescope itself. One of the first is the development of computer simulation software. The development of James Webb was an extremely time-consuming and intricate process, and testing it on ground at scale would have been too complex, even in simulated space-like conditions. This forced NASA engineers to rely on software simulations to understand how the telescope would behave in space. Because of the scope and complexity of testing the James Webb through simulations, the software was pushed to its limit, leading to the advancement of the field of integrated computer modeling as a whole, which has commercial, industrial, and medical applications. Other trickle-down effects that emerged from the development of the James Webb Space Telescope include improved wavefront optical measurement technology to better diagnose and treat human eyes, high-speed laser interferometers and optical sensors that have applications in astronomy, aerospace, semiconductor and medical industries, ASICs integrated circuits that directly led to the repair and restoration of Hubble's advanced camera system, and lastly, near-infrared detection technologies that help us in astronomical observations, earth science, and even national security. All these innovations have far-reaching impacts, not just on our daily lives, but on the pace of advancement in space exploration as a whole. And we have the Webb telescope to thank for all of it. It is important to remember that all this is just a small glimpse into the potential advancement of our species in the coming decades. Hubble has been in low Earth orbit for over 3 decades now, and in that ample time, it has greatly evolved our understanding of the universe. And while the James Webb is still an infant on that timescale, it is already reshaping our core understanding of the universe in aspects such as galaxy formation, detection of black holes, and the birth of stars. And given enough time, the James Webb is poised to become for Hubble what Galileo's telescope was for astronomical observations with the naked eye. And that revolution is one worth waiting for. Thank you for watching this video. If you enjoyed it, please like, share, and subscribe to the channel to learn more about some of the largest breakthroughs and stories in astronomy. And let me know in the comments what you liked about the video. And with that, I leave you for today. I will see you in the next video, fellow astro enthusiasts.